Welcome to today's webinar. The topic today is analysis of steel joints using FE model in Rfem 6. My name is Andreas Hörold. I'm responsible for marketing and public relations in the Dlubal software company. For instance, the Dlubal website, customer projects, the German and English webinars, etc. I will be the presenter today. My two colleagues will support me and they can introduce themselves.
Hi, my name is Walter Fröhlich and I'm responsible for the customer support by phone and email. I'm also responsible for the new add-on steel joints, and I will answer to your questions today in the chat.
And hello, my name is Oliver Metzges. Here at Dlubal, I'm working as a project and customer support engineer, mainly responsible for the steel design add-ons. And now in the webinar, I will be available for your questions in the chat.
Okay, thank you. Then we can switch off our webcams that the attendees can see the full screen. You can ask questions via the control panel on the right side of your screen. You can show or hide it with that arrow here and then enter a question here. My colleagues will answer you. If you don't get an answer during the webinar, because there are too many, you will get an email after the webinar. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. To the agenda today. At first I define a steel joint using the library. Then I define a steel joint using components. The third point is structural and stability analysis and evaluation of results and documentation. Okay, then I turn to the program Rfem. I start with a steel hull, a simple steel hull. It is already designed in Rfem 6, but only the connections are missing. I would like to, I just showed in another model. I would like to create 3 connections on the ridge and on the frame corners. To do that, I need to open the base data. I need to activate the add-on. Here on the right side you can see steel joints, also the other add-ons, but topic of this webinar are the steel joints. The steel hull was designed according to Eurocode and the German National Annex. That's why we design the joints also with the German National Annex. At the moment, the Eurocode 3 is implemented. We will add more standards in the future. I confirm that with OK. And new folders are created. The types for steel joints and here the folder steel joint design. Before I start with the first joint, I go in the design situations. As you can see, the design situation number 1, for that is the steel joint activated, not for the serviceability limit state design. The first design situation contain 10 load combinations. If you want to do the design only for one load combination, maybe where are the highest internal forces, then you could copy, for example, this design situation and copy one load combination, for example, combination number 6, and the new combination is the load combination number 11, and I will assign it to the design situation number 5. Then I go back to the design situations. Steel joints is activated, and I have to deactivate it for the design situation number 1. Okay, I cancel that. I will do it as it was. I can open it again. I would like to do the design for the situation number 1. Okay, then we start with the first steel joint with a right click, or by right click I open new steel joint here, and we come to this table here. At first I have to select one node. I select this node here on the ridge, node number 21. I could also select all 4 nodes on the ridge, but for this example it's sufficient to do it for 1 node. Okay, I disable the members 3 to 6. We just focus on the main connection in this webinar. Then the members. The finite element analysis required at least 1 member to be supported. We can check or set this here. In the created connection, the left side will be supported and the right side will contain the loading. The program will do a cut here and a cut here, and on this place it will be supported, and here are the loads. I will show that later. So material and section, we leave that, and we come to the next dialog, the components. We can create user-defined connection using different components with that button here, for example, at the end. Then you have different modifications, for example, the member cut, the plate cut, plate editor, plate, stiffener, haunch, end plate, fin plate, cleat, plate to plate, auxiliary plane, and welds. We will extend this library in future, of course. Okay, we cancel that. For the ridge joint, we use a template from the library. I open the library with that button here. There are different templates in the library, for example, the rigid joints, pin joints, trusses, all of them are welded. Then user-defined, you can save user-defined components or steel joints. I have got 2 in this library. This add-on is quite new. We will extend the library continuously. A team of 8 members are working on the development of the add-on steel joints. I click through some examples here. Okay. We select the beam to beam and plate to plate for our connection. I press apply template, and I can also apply the material as 355. Okay, it's not done. Okay, I can do that also later. So then member 1 on the left side, member 2 on the right side, and we can modify material, thickness, spacings, welds, etc. So I zoom a little bit in. Now we have got here half angel. We could do it also perpendicular. Yeah, but we use the half angel. You can rotate the plate. Then I choose another material. The thickness of the plate is 20 millimeters. Then the definition type offsets. Yeah, you have more options with the offset, but you can also use dimensions and position. I use the offsets. Top offsets should be -13. And you can see how the graphic is changed automatically. I use the minus offset because I want to be don't want to be in conflict with the trapezoidal sheet with the connection. Okay, then here 20. 10 is okay. I can show it to you. That's quite good. So the width is good, the height. Then the diameter, we have different diameters here available, and I use M16, and the strength grade 10.9. Then the spacing horizontally, I can enter 2 parameters with space, 25, 80, enter, and the third parameter is calculated automatically. We want to use 6 bolts, 3 on every side, then 62, space, 125, 50, enter. So the spacings are okay. I modify the welds, 9, and you can see the welds in which line I am. The welds are highlighted. So 5, 8 below, then 9, the upper weld, 5 for the web, and 8. Okay. Yeah, the connection, all the components of the connections are created. Now we need to define the design configuration. I can edit it pressing that button here. We want to perform a buckling analysis, and the parameters of the standard are displayed. For example, the safety factors here, or the limit plastic strain of 5% according to Eurocode 3. If you want to do an elastic design, you need to set 0 here. We can leave all parameters as they are. We turn to the buckling. For the buckling analysis, we consider the 4 lowest eigenvalues. We could change that also here. And a limit load factor of 15 according to the Eurocode 3. Okay, we can leave the dialog, can do a plausibility check, and now we could calculate the connection, but I skip the calculation time. I open a created file. So the connection is already calculated. In the table below, I can choose steel joints design, and you can see the single design ratios. I can click on one. So you can see the formulas here on the right side for that design check. You can also print it in the printout report, but yeah, I will do that later. So let's take a look at the graphic. Here you can see the graphic. As I said, the left side is supported and the right side contains the loading. Loadings or internal forces in all directions, that's quite important to mention. And you can display or disable components. Now you can see only the welds and the bolts. You can disable also the bolts, and you can display only the welds. So yeah, that should be all for the moment. I will come back to the results later when we have more connections. I continue with a new steel joint. Right-click, new steel joint. I select this corner node here. Okay, and I disable the secondary structure. We focus only on the main members or main connection. So members, yeah, that's clear. One is supported, one contains the loading. Then components. Now, at first, I would like to show you how to create a welded connection. I use a component. I start with the component member cut. I rotate it a little bit. So member cut, I would like to cut member 2, this member, by member 1 on the closer end, not on the farther end. Parallel, that's okay. And I check the welds. I don't modify that in this example. So then the next member cut, member number 1, by member number 2, the farther end in that case, and parallel. Okay, then stiffener. So stiffened member number 1. Reference member should be member 2. Material as 355. Thickness is okay. Yeah, I could leave both, but now the upper stiffener is not okay. And if I select here parallel to the flange, yeah, the lower stiffener is not good. I would like to have it perpendicular here. So that's why I say here lower stiffener. So, and yeah, that should be all. Next stiffener, the upper stiffener. For the upper stiffener, we could use a plate or stiffener. Yeah, in that example, we use a stiffener as for the lower side. So then member number 1, the reference member is member 2 again, same material, then upper stiffener in that case. I did a mistake for the first stiffener. I continue with the upper stiffener. Parallel. Okay. So, and so that's the upper stiffener. I use here 4. And for the lower stiffener, I have to say here perpendicular. Okay, now all should be okay. That would be the workflow of a welded connection, or for the creation of a welded connection. Yeah, but we want to define a screwed connection. That's why I delete all components and start again. I open the library, a rigid connection, of course, in this case beam to column, and end plate column stiffeners. I apply this template and I try it again to change the material here. Okay, now it works. Okay. So now we've got here 3 components and we can modify, or I start with the end plate. So let's zoom a little bit in that you can see the changes. Member number 2, reference members number 1. Material is okay, thickness is okay, top offset again -13, bottom offset I select or enter 15, then left offset I rotate a little bit that you can see the changes, 25, 25 on the opposite side. So then again M16, but I need to modify the strength grade to 10.9. The horizontal spacings are okay, but I need to change the spacing vertically. I want to move that bolt here upwards. So that's why I enter 60 space 50 space 400, enter. So now it should be okay. Then the welds 7, 5, 7. Okay, that's all for the plate. Then we continue with the member cut. Member number 1 by member number 2. So, and the offset should be 0. That's okay. So then the stiffener, I use only that one for the upper stiffener, the parallel direction. And what I need to change, only the weld 4, and that's all. And I need to create the lower stiffener by a component. Stiffened member is member number 1. Again, reference member number 2. Material is the same. Thickness 10 is okay. Lower stiffener. Perpendicular. So it's okay. Yeah, and the rest is okay as well. We use the same design configuration. We do a plausibility check. All is okay. So, and we enter a third connection. I say here, create new joint. I select one node, the opposite node. I zoom a little bit in and show you what I did here. Or maybe with the solid model. At the moment we can connect round cross sections. We will do, or we will implement it in future. That's why I use for this short member here a plate as member. Okay. I disable the bracings. Okay. Yeah. Member number 1 is supported and the other members contain the loading. We leave the material and the sections as they are components. So now I load steel joints from the library. So user defined. I've got only 2 templates here and I use that template here with an haunch. So I apply the template. Say OK. Design configuration should be the same. Let's take a look at the components. Where are several components now in that connection here? We can do a plausibility check. No errors found. Okay. So now we could calculate our, but again I skip the calculation time. But you can see already the connections here. So I change the window. Those are the already calculated connections. We go in the table again. Steel joints design and the stress strain analysis. Now we are in the table design ratios by joint. I can also use here design ratios by loading, design ratios by node, and design ratios by components, whereas every single component displayed. So, and if I double click on that line here, for example, the result table should be opened. Okay, and you can see the design check with the formulas And this table is interactive. If you go in another line, the design check for this component is displayed. Then this line, for example, and so on. And you can go in the graphic. So that's another window. Okay. And you can see the design ratios here on the left side. And you can disable, for example, the members, etc., as I showed before. So, but let's take a look at the buckling shapes. I select here the buckling analysis. Joint number 1. All values are over 15. For the joint number 2, the buckling mode or the critical load factor is lower than 15. That's not okay. And we can go in the graphic. Yeah, and you can see the mode shape here. That's why I created another connection with the flange here and the haunch. And for the other connection, all is okay. Connection number 3, where's the lowest value? Here. It takes some time because of the webinar software, I think. So, and now you can see the mode shape with the critical load factor, and this area is red, but the mode shape is okay. The value is higher than 15. So then what I need to show as well, you can save the results in the steel joints to see the FE model, and if you save that, I can close that and open that FE model that you would saved. So that's, for example, the FE model with surfaces and so on. The member number 1 is supported on the lower side, and these members contain the loading, and as you can see, in all directions. I open materials. So plastic material for all, then shank 10.9, the spokes, and the welds. So that model is calculated in the background, and you get the results in steel joints. I go back in my model. And then you can design or create a printout report. On the left side you see the printout report. I've already created one. Now only with the main topics and the steel joints design. I can click a little bit. I printed the models of the joints. And here the steel joints components, the component properties with all spacings, strength grade of the bolts, and so on. So then I scroll down. The design situations, the used load combinations, the static analysis settings. I switch here to the main point, steel joints design. Then you can see the design ratios by steel joints. Then the more detailed design ratio on steel joints by components. You can see all design ratios of the components, or of all components. Then the buckling results. Then I printed some graphics with results for the single connections. And I would like to show how to do that. I move the printout report to the other screen. It's interactive. I can work in the Rfem 6 window, and the printout report will be changed. So maybe an isometric view of that connection here. So, and I say print to printout report. Not the full page height, only 50% of the page. And I say save and show. So, and then it is printed in the printout report. Okay, then you can also print the formulas. Oh, I turn back to the program. So, formulas. Go to the steel joints design, stress strain analysis. I open, for example, that formula. So, and I can print that. So, and you can see now the sheet with the formulas. And you can do that for all formulas that you want to document. You can also do a screenshot of the result graphic. At the moment we can't print that graphic directly in the printout report. We will implement that, of course, in the future. But at the moment you can also do a screenshot of that window here, copy that on the clipboard, then go in the printout report and insert image from clipboard. I say connection. Okay, and you can see the connection here. Yeah, but we will implement the direct print in the future. So that should be all for the presentation to give you short overview what is the current state of the add-on module. I would like to give a short outlook. As I said before, the add-on steel joints is constantly being forward developed. As I said, a team of 8 members working on it. In future, we will extend the component and template library, for example, with base plates, round cross sections, etc. Then we will integrate the dimensioning of the components, also the calculation of the joint stiffness, SJ-INI, and the automatic transfer to the structure. That means an interaction between connection and structure is considered. Then we will implement the pre-stress of bolts. We will implement other standards, etc. It will be developed continuously. I would suggest just download the trial version, or if you already have got Rfem 6, ask our sales team for a trial version or a trial period to use the add-on steel joints. I would like to show all who don't know where you can find the free trial version on our website, dlubal.com. Here above, you can click on the free full trial version. You can try Rfem 6 with all add-ons for free for a period of 90 days. And then you can request for future features, for example, in the add-on steel joints. Here under support and learning, you can submit a program feature or idea. You can also do that from the program side. For example, when you open the Dlubal Center, and you have already registered for the account and you have got an account, you can see here the messages, your data, the licenses, products to download. And under development, you can see the implemented features, open features, and you can submit your wished feature, for example, for steel joints. Okay. So then at the end, I would like to show you how you can find the recording. We recorded this webinar. You will get an email with the link to the page that I will show you. You will get a certificate. So under news and events, there are the webinars. That's today's webinar. And you will get the link in the next days to that page here. The recording will be here in the middle. Then you can already find the files of the connection here. And just try the models with the trial version, etc. and use the recording to repeat all. Okay. Then I would like to say thank you for your attention. Thanks to my 2 colleagues for answering the questions. I wish all a nice rest of the day. Maybe we can hear each other or see each other in the next webinar or one of the next webinars, we will send you an invitation. Yeah. Have a nice day again, and bye-bye.